So let's go through an example tying these ideas together. So we have this data that has recorded distance from Baltimore as well as the price of the flight. So we could read is Atlanta, that is 576 miles from Baltimore, and it costs $178 in airfare. And then like Denver is 1,502 miles from Baltimore, and that had an airfare of $258. So, just given this data, let's talk about figuring out our explanatory and response variables. Again, most often it's going to fit the order that they give you it, but just to kind of think critically about why which is which. So explanatory variable, that's our x variable, response is y. So what we'd want to do is just think about which could explain change in the other. So if I said distance explains change in airfare, that makes sense. If you increase or decrease the distance away from Baltimore, you'd expect a certain change in airfare. Typically it goes if you travel further, you pay more. And if you travel closer, you pay less. If I had switched that around, so that implies that, so distance explains change in airfare, so that would make distance our explanatory variable, and airfare the response. But if I just think about what if I had switched those, if I had said airfare explains the change in distance, that would be the idea of setting a certain airfare, and then that would change how far you travel. If we just think about like how we buy plane tickets, you could think of sequence of events here as well. You'd determine the distance first. You'd figure out how far you are traveling, and then the airfare would change based on that. It wouldn't be likely that you would go to an airline and say, I am spending $300 on a ticket, choose how far I can travel. That would be an unlikely scenario. It's not impossible, but it's typically not what happens when buying tickets. So with that, that sets the explanatory and response. So then from there, what we're going to do is look at scatterplot, correlation, and coefficient of determination. So with that, we're going to need to go to GeoGebra or some form of technology to get these values out. So in GeoGebra, if we go to spreadsheet, what we'd want to do is type in our data. Again, all of your x values should be in column A, y values in column B. Then we'll want to highlight our data and then go to our histogram image up above here and choose 2-variable regression analysis. And with that, our scatter plot will open up. So what we can see is our scatter plot. I mean, it's pretty spread out, and again, this small data set, but it does look roughly linear. I can kind of visualize a line that would go through that data that would somewhat fit it. What I just want to be careful of is that there's no obvious curving to the data, which there isn't here. So there's our scatter plot. In fact, I'm going to go ahead and if you want to, I use a screen grab technology on my computer, but if we just wanted to grab a picture of this, which I probably could have done better with that, but just real quick, you can copy and paste from there. And I'm just going to put that in here so that we can refer to it if needed. So there is our scatter plot. All right, so from there, we have our scatter plot. Now we want to analyze correlation. So we need our value for R. When they ask you for, in the long word is linear correlation coefficient, but usually in short, they just say, like, what is the correlation? So to answer that, we need R. So if we go back to GeoGebra, this is where we'll go to the summation X symbol that shows statistics, and then look for R, which is a 0.6953. So that answers our question of what is the correlation, 0.6953. Then what we can do is use that to write a brief description of the association. So we could say is the association between airfare and distance. airfare and distance is, and this is where we want to go to our number line. So I'm going to jump back to the document we just made of here's our number line, and thinking about where 0.6953 would land. Well, that would land somewhere in here. So with that, we'd have moderate strength and a positive direction to it. Again, if R comes out to be negative, it'll be negative direction, positive is positive. So sign is kind of simple here, but getting used to the strength is the trickier part. So we're going to have moderate strength. So the association between airfare and distance is positive and moderate strength. So with the direction, we can get an idea of that we have an overall increasing trend, but then in terms of the strength of it, it's linear, but it's not particularly strong, but it's not weak either. We're in the middle in terms of strength. All right, coefficient of determination, that's R squared. So we want to take that 0.6953 squared, so we'd plug that into a calculator, which is 0.4834. So then to interpret, what we're thinking about is the percent of variation in Y explained by X. That's overall what we want to think about in our interpretation. So Y for us is airfare and X is distance. So I would take that 0.4834 and change it to a percentage. So 48.34% of the variation in airfare can be explained by distance from Baltimore. All right, so that's how, given data in terms of two variables, we can look at the scatter plot, we can evaluate correlation, and we can evaluate coefficient of determination.